Okay, so this is an example for method of sections. So here we have a truss framework in here, and it's got 3 loads on the top, 10 kilonewtons, 20 kilonewtons, 10 kilonewtons, and 2 attached to the bottom, 15 kilonewtons each. Supported left hand end and right hand end. So first thing we must do is find our reactions. So typically we will take moments to do that. So you just do your standard moments for a free body diagram, and you'll easily work out that your left and right reactions in this case are both 35 kilonewtons each. Okay, method of sections. What we're trying to do with method of sections is to find the force in one or more of the members of this framework. So in this case here, I want to find the force in members A, B and C. So I'm not interested in all these other ones. I'm only interested in the forces in A, B and C. We can use method of joints, in which case we would have to start at one corner and solve this joint, solve the next joint, solve that joint, solve this one in order to find these 3. So method of sections enables me to take a section through my frame and just immediately solve the 3 forces that we want. So to do method of sections, the first rule is if I'm trying to find the force in member A, then I must cut that member and then cut through the framework, so I cut 2 more members, or no more than 2 more as I go. So I can go through this way and cut those, or I can go down through here, which makes more sense because I'm now going to cut the 3 that I want to find for this problem. So we'll just redraw that into here. So I've now cut my framework, and I will get left with just this portion of my frame. Shorten that a little bit. Stick on all my forces, so my free body diagram is still correct. 20. And now we've exposed these internal forces. So we'll have FA, FB and FC. Now at the moment I don't know the direction of those forces, so what we're going to do is just take a blind guess really, and we're just going to say, well, I'm going to make them all go outwards this way. If we get this wrong, then it won't matter, because when we do the maths, if the force comes out negative, it just means that it's in the opposite direction. So first one we want to find is force A. To do that, what we need to do is to take moments about the point where the other 2 forces that we don't know cross. So I'm trying to find FA, FB, line of action of FB, line of action of FC, take moments about this point. When I do moments, therefore FB and FC will have no moment about that point, so I don't need to know what they are. So this is my moment point. So take moments about there. Each one of these links through here is 1 meter. This one is 1 meter. So sum of moments equals 0. Or I can write this as moments clockwise equals moments anti-clockwise. So about this point, clockwise, I will have 35 times this distance going clockwise. I will have FA is going clockwise. My 15 will be anti-clockwise, my 10 is anti-clockwise, and my 20 is anti-clockwise. So moments clockwise will be 35 times 2 meters across here, plus FA times this height, which, given my frame is a 1 meter by 1 meter triangle with 60-degree angles, it's 0.866 high. So this distance here is 0.866 0.866. So FA times 0.866 will equal my moments anti-clockwise, which will be 10 times the right angled distance, which will be 1.5 meters. So 10 times 1.5 plus 15 times 1 meter plus 20 times half of that distance, which is 0.5, which if you rearrange that, you will get FA, which is equal to 34.64 kilonewtons. Sorry, negative 36, which is telling us that the force is actually in the opposite direction to the arrow. So we assumed an arrow this way, so in fact FA will equal 34.64 kilonewtons going that way. So we'll draw that onto the frame at the end. Let me do that. Next one we'll do will be FC. We have a look at FC. Put my framework back in. (15, 35, 10, 20). FC. We've got these forces that we're trying to find. If I'm trying to find FC, then our method says to take the moment point where the other two cross. So FA and FB will cross at this point. So I'm going to make this my moment point in order to find this force. So again, moments clockwise, moments anti-clockwise. Clockwise moments, we need to actually just check FC. We said FC on this diagram was going left to right, so we'll put that down there. Moments clockwise will be 35 times this distance, which will be 1.5 meters, and that's it. That one's anti-clockwise, that's anti-clockwise, and FC is anti-clockwise. So we'll put these on this side. 10 times 1 meter, 10 times 1 plus 15 times distance between 15 and the moment point, which would be 0.5, 15 times 0.5. My 20 is acting through my moment point, so that doesn't count. And FC times 0.866, the height of my frame. So FC times 0.866. This will give me FC, which is equal to positive 40.4 kilonewtons. Now, positive means that my arrow was correct. So my direction is actually correct for that one. Okay, that's FC. Now we'll have a look at FB to find that. So to find FB, if we redraw our framework, again 35, 15, 10, 20, FA, FB, FC. The method says that we need to find FB, we need to take moments about where FA and FC cross. Now, these two are parallel, so they're never going to cross. So we're a little bit stuck at this point. What we're trying to do though is a free body diagram. So part of free body diagrams is sum of moments equals 0. It's also that my sum of forces must equal 0. So simply what I can do is FB on an angle, I can break this down into a horizontal and a vertical part. So we assume that FB was going this way, so the vertical part of it will go that way, horizontal part will go there. So this will be FB in the Y direction, in here. So we're just going to do sum of forces equals 0, or if you break that down, sum of forces in the X equals 0, sum of forces in the Y equals 0. I'm just going to look at the Y directions in this case. So I'm looking for forces up equal forces down. Forces up, I have 35, 10 is down, 15 down, 20 down, and this one is down, the FBY direction. So forces up 35, forces down 10 plus 15 plus 20 plus FBY. Rearrange this, FBY is equal to negative 10 kilonewtons, i.e. since it's negative my arrow must be the wrong way, so FBY must equal 10 kilonewtons going up. So if we have a look at this little arrangement here again, just redraw that. Here's my FB, this is 60 degrees, we said this was 10 kilonewtons, this is my little force triangle, therefore FB sine 60 equals 10, we know that's going up. If that's going up, this one must be going that way, FB must be going that for its components to be that way. Take this, rearrange it, we find that FB must equal 11.54 kilonewtons. So that's the size of my three. We just need to now look at the whether they are in tension or compression, and to draw these back on our framework. So here's my framework. Draw my whole framework in with my forces. So what we've worked out is FB we said was going up, so it's going up that member. So we cut that portion of the framework off. So the arrows we're putting on are on this end of those members. So this one is going up. FC, back here, FC we worked out that it was in the correct direction, it's going that way. So on here FC is that way. And we also looked at FA, and we worked out that FA was going to the left, wasn't in that direction because it was negative, so it's going left, so that's going that way. So if this end of the member is going up, this one will be going down, that one's going right, this one will be going left, that's going left, that one will be going right. This one will be in compression, this one is compression, this one is tension. So 11.54 and 40.4 kilonewtons and 34.64 kilonewtons. And that's method of sections.